In Lesson 2-4, you'll be dividing positive and negative fractions. Before we get to actually dividing positive and negative fractions, we're going to first talk about multiplicative inverses or reciprocals. A number and its multiplicative inverse, when you multiply them, it equals 1. For example, 3/4 times 4/3 equals 1. 3/4 and 4/3 are multiplicative inverses. Basically, you take a fraction and flip it upside down, and you have its multiplicative inverse or reciprocal. So our first example asks us to find the multiplicative inverse of -5 2/3. Before we can do that, we need to first change the mixed number to an improper fraction. Remember, you do that by going times plus, keep the same denominator. So 5 times 3 is 15, plus 2 is 17. Keep the denominator the same. And this was a negative, so I'm going to make sure to put a negative here. Now, the multiplicative inverse is going to be this fraction flipped upside down, and it was negative, and so its multiplicative inverse also needs to be a negative, because a negative times a negative is a positive, and a number multiplied by its multiplicative inverse equals a positive one. So -3/17 is the multiplicative inverse of -5 2/3. -2 1/3 needs to be changed to an improper fraction first. 2 times 3 is 6, plus 1 is 7. And once again, it was negative to start with. Now the inverse is going to be to flip that upside down, and we want to keep it a negative because a negative times a negative is a positive. -7/3 times -3/7 would end up being 1. So this right here is the multiplicative inverse of -2 1/3. The multiplicative inverse of -5/8, we're just going to flip that upside down, make it 8/5, and it's going to have to be negative because a negative times a negative is positive, and we're looking for a positive one when we multiply them together. The last example of this type is a whole number. You would write that as 7/1, and now flip it upside down, and you get 1/7. The multiplicative inverse of 7 is 1/7. The reason we're talking about multiplicative inverses in this lesson is because in order to divide fractions, you multiply by its multiplicative inverse. A little poem that a student taught me several years ago was, "Dividing fractions, easy as pie, flip the second and multiply." Another way that we've come across that's helped kids remember how to do this is KCF, not to be confused with Kentucky Fried Chicken. KCF stands for keep, change, flip. Keep the first fraction exactly as it is, change the division to a multiplication, and flip the second fraction to its multiplicative inverse. So in our first example of -4/5 divided by -6/7, the first thing you're going to do is change it to multiplying by the multiplicative inverse, or dividing fractions, easy as pie, flip the second and multiply. Once you do that, now it's the same thing as we did in the previous lesson. You look to see if there's anything that can be simplified before you multiply. For example, the 4 and 6 both can be divided by 2. 2 goes into 4 twice. 2 goes into 6 3 times. And then a negative times a positive is going to be a negative, because bad things happening to good people is bad. Then 2 times 7 is 14. 5 times 3 is 15. -14/15. Now, when I was in middle school learning about dividing fractions, I was told the same thing. Flip the second and multiply, but I had no idea where that came from. So I'm going to show you why that works. Negative 4/5 divided by 6/7 can also be written like this, because remember, a fraction sign, fraction bar is also division. So if I were to take this division problem, negative 4/5 divided by 6/7, if I were to go and multiply both the numerator and denominator by the same thing, I would end up with something equivalent to what I started with. So I'm going to go ahead and multiply the numerator and denominator by 7/6. The reason why I chose 7/6 is because on the bottom, when I multiply 6/7 times 7/6, you end up getting 1 on the bottom, because a number multiplied by its multiplicative inverse is 1. On the top, when I multiply these two fractions, you'll notice this right here is the exact same thing that we had over here. So we ended up with negative 14/15 when we multiplied that. And negative 14/15 over 1 is just negative 14/15. That is why it works to multiply by the reciprocal, or the multiplicative inverse. In our next example, we have mixed numbers. And before we can flip it to multiplying by the reciprocal, we need to first change our mixed numbers to improper fractions. 4 times 3 is 12. 12 plus 2 is 14. And then 3 times 2 is 6, plus 1 is 7. And let's not forget that that's a negative fraction. Now at this point, now we can do keep, change, flip, or dividing fractions, easy as pie. Flip the second and multiply. Again, it doesn't really matter where the negative is, if it's on the top, bottom, or in the middle. It just means that fraction is negative. And a positive fraction times a negative fraction is always going to be a negative fraction. Before we multiply, we can go ahead and simplify the 7 and the 14 by dividing both by 7. 7 goes into 14 twice. 7 goes into 7 once. Then 2 times 2 is 4. 3 times 1 is 3. And we had already said it was going to be negative. This, though, is an improper fraction. 3 goes into 4 once, with 1 left over, keep the bottom the same, and of course it was negative. So negative 1 1/3. I threw an extra example in over here because it has a whole number in it. That whole number can be written as a fraction by putting it over 1. But before we do the keep, change, flip, or dividing fractions easy as pie, we need to first make this mixed number into an improper fraction. 1 times 2 is 2, plus 1 is 3. And since it's negative, I'm going to make sure I write negative 3/2. And then we're going to flip the second and multiply. Before we multiply, we can simplify. The 3 and the 12 both can be divided by 3. 3 goes into 3 once. 3 goes into 12 4 times. And when we multiply across, we have a positive times a negative, so it's going to be negative. 1 times 1 is 1, and 2 times 4 is 8. Negative 1/8. Now the last example says Lina's class is making flags for the school's International Day celebration. She needs 1 1/6 feet of paper for the blue portion of each flag. If the class has a 21-foot roll of blue paper, how many flags can she make? Well, if we want to know how many she can make, if each one needs 1 1/6 feet, we're going to take our total amount of paper, which is 21, and divide it by 1 1/6 because we want to know how many 1 1/6 go into 21. And then before we go to solve this, we want to write our whole number as a fraction, and we want to change our mixed number to an improper fraction. So this is really 21 over 1 divided by 1 times 6, which is 6, plus the 1 extra, which is 7, over 6. And now we have to do keep, change, flip, or dividing fractions, easy as pie. Flip the second and multiply. We can do some simplifying ahead of time. The 21 and 7 both can be divided by 7. 7 goes into 7 once. 7 goes into 21 3 times. Now multiply the numerators. 3 times 6 is 18. 1 times 1 is 1. 18 over 1 is just 18. We can make 18 flags. Example 5. There were 4 persons working on a remodeling project. It took them 6.5 days to finish the job. How long would it take 6 persons to finish a similar project? Well, if it takes 4 people 6.5 days, we're going to figure out how much that is total by multiplying 6.5 days times 4 people. So 4 times 6.5. We need to change the 4 to a fraction, and we need to change the 6.5 to an improper fraction. 6 times 2 is 12, plus 1 is 13. Keep the bottom the same. Simplify before multiplying. 4 and 2 both can be divided by 2. 2 goes into 2 once. 2 goes into 4 twice. Now multiply across the numerators. 2 times 13 is 26, and 1 times 1 is 1, or 26. Now we want to take that number of 26 and divide by 6. If we divide it by 6, that's going to tell us how long it would take for 6 people to finish that job. 26 divided by 6. 26 divided by 6 can also look like this. 6 goes into 26 4 times with 2 left over. Keep the bottom the same. And then simplify the 2/6 by dividing by 2. And you end up with 4 and 1/3. It's going to take 4 and 1/3 days for 6 people to finish a similar job.